Hello guys, welcome to my channel Next Gen Style.
Hello friends, today we will see the concept of graph coloring with backtracking. This is one type of CSP problem. CSP, that is constant satisfaction problem, in which we will be provided with some constraint or condition that we need to fulfill. So in this case of graph coloring problem, we will be having three colors, suppose RGB, red, green and blue. And we are given with this graph. Okay, so we have to color this graph using these three colors. So what we will do and what are constraints for coloring this graph, we have to use only these three colors RGB, and no adjacent side or no adjacent nodes should have same color. If node 1 and 2 are there, then these first and second node should not have same color. So this is constraint that we need to follow. So this is basic idea of graph coloring, and in backtracking we need to check with possible colors. If we don't get, then we will backtrack for finding other solution. That is concept of backtracking. So in this tree here we can see we have colored this graph using different combinations of colors. So for this graph we need to find out search space tree so that we will get all possible solutions for coloring this graph. So we will start with first node x1 is equal to r. So if we give color red to this first node, then we will check for next node x2, which color we can give to x2 node. So if we give red color to x2 node in next step, then is it possible? No. So just because already we have red color, so no adjacent node should have same color. So we will make it cross for this search space tree. Then we will check with next color green. Yes, we can give green. So just make it tick. We will check with blue. Yes, we can give blue. In same way, we will move to next for x3 node. If we give red color, is it possible? Yes, because here green color, so we can give red color. So we will make it tick for red color. Green color already it's there, so we can't give. Blue color we can give, just make it tick. Then we will move it x4 node. For all possible solutions, we will check red, green and blue. So already red is there, so we can't give red color, so we will make cross. Green, yes, we can give, and blue also we can give. In same way we will check for blue. X4 is equal to RGB. So can we give red? Yes, we can give. Green, yes. Blue we can't, already we have. So in same way we have to find out for all remaining nodes. So we will get all possible solution. Wherever we have tick, we can move with that node for next possible solution. Okay. So this is we have done for red color. If we give red color at starting, but if you start with any other color, green or blue, then you have to create that search space tree for remaining colors, green and blue. So we will get these combinations for coloring this graph in this way: red, then green, red and green, R, G, B, G, R, G, B, G. In this way we will get all combination, total 6 combinations we will be getting with this search space tree. In same way you can calculate for green and blue color also. Then again you will get different combinations for coloring this graph. So this is the concept of coloring graph with backtracking. Thank you.